All right, now we're on to integrals of natural logs. So basically, log rule for integration. The integral of 1 over u du is ln of u plus c. Yes, the absolute value piece is in there. Okay, has to be in there because basically it could be either one, just like we had shown you with derivative, how it comes out. That's how you do it. All right, so something like this. You can move that 5 out in front. So it really is 5 times the integral of 1 over x dx is just 5 ln of x plus c. Yes, we will use u substitution. Okay, this one right here, 2x and x squared. So if u equals x squared plus 3, du is 2x dx, dx is du over 2x. So when you plug this in, you have 2x over u times du over 2x. The 2x cancels. You end up with the integral of 1 over u du, which is ln of the absolute value of u. So I'm going to plug that in, x squared plus 3 plus c. Okay. Number 3, secant squared and tan. You want to think, oh gracious, is there a derivative in there of one of them? Is one of them the derivative of the other? Yes, the derivative of tan is secant squared. So you would let u equal, sorry about that, u equal tan of x. Du is secant squared of x dx. So dx is du over secant squared. So you have the integral of secant squared over u times du over secant squared. Those cancel. Now you're taking the integral of 1 over u, which is ln of the absolute value of u. So ln of the absolute value of tan x plus c. Okay. Easy enough? Hope so. Of course, though, we have some special circumstances. When it's one like this, the numerator is equal to or greater than the denominator. You want to divide that out first, because if you look at that, those are the same. There isn't a u where the other one would cancel. So one like this, which you will rarely have to do this. I just feel like it's my job to show you. You would divide that out. So divide that out. Yes, actually use long division and divide it out. I don't know if you remember doing this. X squared goes into x squared 1. So that's x squared plus 1, and we subtract. So x squared minus x squared, you get x, 1 minus 1. And then x squared does not go in there, so that's your remainder. So you would get 1. So you would do the integral of 1 plus x over x squared plus 1. Maybe you kind of remember that. Okay. Bigger than that, though, I do, more importantly, I want you to see that how to integrate from here. Okay, so to integrate from here, you get the integral of 1 dx plus the integral of x over x squared plus 1. So integral of 1 is just x. Here you're going to use u substitution. U is equal to, sorry, I don't know why this is acting up. U is equal to x squared plus 1. I'm going to write. So du, there we go. So du is 2x dx. So dx is du over 2x. So you have the integral of x over u times du over 2x, sorry, over 2x. You get an x cancels, maybe. Okay, so you're going to have 1/2 the integral of 1 over u du. So this is going to be plus 1/2 2 goes here. And it's the integral of 1 over u is ln of u, which is x squared plus 1 plus c. Okay, so really don't be as concerned if you didn't get this piece over here, the division. It's more now being able to integrate. Okay, now this next one, use substitution with the log rule. So same thing here. We have x times ln of x dy equals dx. Okay, is that everybody okay with that piece? So from there, you need to get dy by itself, so we would divide by x ln of x. So we have dy equals 1 over x ln of x dx. From there, you integrate. Now, have no idea. So think about it. We have x and we have ln of x. Well, that's basically 1 over x, right? So if we let u equal ln of x, du is 1 over x dx, that's going to end up canceling. Okay, so let's start with that. U equals ln of x. Du is 1 over x. So x du equals dx. So integral of dy is y. Here you're going to have 1 over x times u times x du. That x cancels. Okay, so the integral of 1 over u is ln of the absolute value of u. U is ln of x plus c. Okay, so yes, this is more practice with u substitution. Okay, all using ln of x. So change of variables. This one right here. Again, looking at what that is, I'm not really sure. I'm going to start with u equals x plus 1. Okay, so du is just dx. Doesn't help me out because now I have 2x over u squared times du. So take this, u minus 1 equals x. So I have the integral of 2 times u minus 1 over u squared du. I'm just going to move the 2 outside. U over u squared is u to the negative 1 minus 1 over u squared. Actually, no, hang on. I am going to leave it as 1 over u. So u over u squared is 1 over u, and then minus, I can write that all together. Don't need that. Okay, sorry, here we go. So what I'm doing here is I move that 2 out in front. Okay, then I have u minus 1 over u squared, which could be u over u squared minus 1 over u squared. Okay, u over u squared is 1 over u minus 1 over u squared du. Now, the integral of 1 over u is ln of u, right? But this is not. Okay, don't start being ln happy when you're doing the integral of something on the bottom. Because remember, 1 over u squared is just u to the negative 2. So that is going to end up being minus u, so plus 1 here would be to the negative 1, and negative goes out in the front, so it becomes plus 1. Okay, and then of course plus c. So 2 ln of x plus 1 plus 1 over x plus 1 plus c. Okay, little lengthy there, but oh, and don't forget it's 2 times that whole thing. So this really should be 2 over that. Okay, so there's an example there. All right. As you do more practice, you'll see most of the ones you're going to do are more like, the beginning ones. Again, you may see that dividing, you may not. but I just felt like I needed to show it to you. All right, so next slide, maybe. Okay, this pen is going crazy. Give me a minute. Turn over to the next page. I might have to stop here. I'm going to pause. Maybe not. Okay, so I'll come back to that in the next video.